the problem says that we have a flask made of Pyrex that is at a temperature of 20 Celsius, and we fill it with acetone, 100 milliliters of acetone that is at a temperature of 35 Celsius. So we need to find the final volume of the acetone after it is exposed to a change of temperature. So we know that the change in volume is going to be the final volume minus the initial volume. So for this equation we can solve that. Final volume is going to be initial volume plus delta volume. So we also know that the formula of expansion, of volumetric expansion in thermodynamics is going to be beta times the initial volume times delta T. So we can substitute in here. So we are going to have a final volume. It's going to be initial volume plus beta times volume times delta T. So we can solve for that because we have the initial volume. So it's going to be 100 milliliters plus 100 milliliters times the beta of the acetone, that is going to be 1.5 times 10 to the minus 4 times the change in temperature. The final temperature is 20 because it's cold until 20 times, and the initial is going to be 35. So if we solve for that, we are going to obtain the final volume, 100 plus So the final volume is going to be 99.775. So, and we also have to calculate the rate of change between the volume of the acetone and the volume of the flash. So we can put that delta volume is going to be beta times initial volume times delta T divided by beta times delta T. This is acetone and this is flask. If we know delta T will be the same, volume was, so we are going to get only beta times divided by beta. So we know the beta of the acetone, that is 1.5 times 10 to the minus 4. But we have the alpha. The alpha is 3 times beta. So we're going to have that it's 3 times 3.20 times 10 to the minus 6. So if we solve for that, it's 1.5 times 10 to the minus 4, divided by 3 times 3.20 times 10 to the minus 6. And this is going to give us the rate of change, that is going to be 15.6025 without units because it's a rate of change. And that's it.